Shockingly cheesy. Cheesy boys.
The Jamaica Observer Study Center Online is giving you more. CAPE Mathematics and Management of Business have been added to our Study Center Online to better prepare you for your final exams. Gain access to over 10 free CSEC and CAPE lessons, available this and every Tuesday. Visit us at jamaicaobserver.com/studycenter or contact us at 876-844-2107.
So once you have both of them have the same algebra term, they are parallel. Okay? Last one is collinear. How do we prove collinearity? To prove line the same line, 3 points form on a straight line. This in CXC they call it collinear, collinearity, collinear. That means all of the 3 lines. So in other words, how do you prove that A, B, and C are on the same line? All you need to prove that there's a relationship between any 2 pieces of the line. Or when I say relationship, prove that they are parallel, meaning that they have the same components, same component, or same algebra term. So when you work out AB, if you get, for example, 2A, and you work out BC, and you get 3A, then you know that they are collinear. So they are, in other words, they must have the same algebra term, or if you work it out in terms of matrices, they are parallel. They have the same gradient. Next. All right. Let us look at this one. B is the midpoint of AC, right? M is the midpoint of PB. Find PB in terms of A and B. PB is, you go from P to A, then A to B. That's straightforward. A. So that's going to be minus 3A, right? And let's now show that N, M, and C is a straight line. In other words, prove CXC would say collinear. So to prove that they are N, M, and C, that's N, that's right there, M and C. So if you were to draw a straight line across, they will be a form. So how do you prove it? Let's look at how you prove it. So first you find, so what they are proving, what they have done is broken up into 2 pieces. They are broken up into NM and NC, right? NM and NC, okay? So B is the midpoint of AC. What does that mean? It means that if AB is equal to A, then BC is equal to A. That's common sense right there. So, what is NM equal to? NM, and I'm going to say M is the midpoint. So we have 2 midpoint C, and you got what? 2A minus B, right? They are parallel, and they have a common point. N is common, so it's a straight line. Notice the explanation says NC is a multiple of NM. Multiple, no problem, because that means it's a scalar. But the fact of the matter is, they have the same component. What is the component? A minus B. Okay? A minus B. Very straightforward right there. All explanation is written right there that you can see. Right? Right there. So, look at this one again. Find ON. Prove that's a straight line. The other one. So you found ON and OD. All right, so you can take a camera shot of this one. So, as I said, a workshop with that we weren't expected to do everything in vectors, but we were supposed to do the basic ones so that you can understand what is happening, right? So if you have any further questions, we want to try and make the PowerPoint available to you so that you can do it's the same concept. Same concept of straight line or collinear. You just need to prove any 2 pieces of the line. I want to prove any 2 pieces of the line. and they have the same component, it is collinear. All right. All right, so we're going to be closing off here. So thanks again for listening to this segment. We might be going a little bit fast, but the idea was just to make you get some exam practice and to look at some questions. All right, want to call it appetizer. Thanks again.
Cheesy balls. National cheesy balls. National cheesy balls. Shockingly cheesy. Cheesy balls. National cheesy balls. National cheesy balls. Shockingly cheesy.
Measure. First, you have to look where the object point is and where the image point is. Look where the object point is and look where the image point is so that you can know how much the object turns. Okay. Dilation, same thing we call enlargement. Enlarge, it have a scale factor. And the scale factor, when the scale factor is greater than 1, we say it's an enlargement because it is greater than 1. If the scale factor is less than 1, what we say it is? We say it's a reduction, right? Or the image gets smaller. Okay. So let's look at that. Those two shapes, A, B, C, and C, E, F. The object gets larger. If you notice, the object and the image gets larger. In CXC exam, they could ask you to find something known as the scale factor. What is the scale factor? The scale factor is a number that increases or decreases the object and the image. I have to say increase or decrease, because it depends on which one is the object and which one is the image. Because if the image is smaller than the object, then you know, so the thing gets smaller. So obviously that must be a fraction in some cases, right? So how do you find the scale factor? All right, let us look at the one on the left with a curved arrow. Let us say we have RC double, and we have ACB. So let us say RC double was the object and ACB is the image, right? Now, if they're going to ask you for the scale factor, what you do, you look for a side on the object and a side on the image, and you divide it. So we're talking about like C double and CB, C double and CB, or we're comparing RC with AC, or we're comparing R double with AB, and then you divide and then you come up with the scale factor. Depends on which one comes first. Okay, the one that comes first is at the top, and the one that the image goes below. All right. Okay, so all right, and this is just an example of the dilation image will be enlarged by absolute values, meaning that absolute values that we try to avoid fractions. Okay. All right, so we're going to be looking now at some examples of what type of questions you could get in the CXC exams, right? Because a lot of the times when we get questions in CXC, the issue is how do we approach the questions, and sometimes as a result of we panic when we see this, because you see the transformation geometry questions, students, the transformation geometry questions sometimes they can be problematic in the exam. Why are they problematic? They are problematic because they can, what's the term now? They can cause issues as far as interpretation. Okay? Interpretation. And in an exam situation, when we panic, we tend to, what's the word now? In an exam situation where we panic, we tend not to do the right thing. And that in itself can cause problems because exam time is coming down on us, and instead of us trying to settle down and to answer the questions properly, what we do, we tend to misunderstand the questions. And that causes all sorts of other issues. So let me just go through this quickly. Okay, so let me just go through this quickly with you. All right. Translation, right? It says a translation usually, and I said it's normally a column vector. I know it is right there, 3, 1. So it means that the object moves 3 on the right and 1 down. Okay? Okay. So what does that mean? It means, let us say we have, what is the vector translating A to B or from B to A? So let's look at this. So if we're looking at the first one, it will be positive 3, and it will do what? Minus 4. Okay, this is what the question says. What is the vector translating A to B? Right? So there are two ways the question can be given in an exam. And this is an interesting situation. You can just be given the question written down, or they can give you a picture of the diagram there, and then you have to identify the coordinates and figure it out. Right? So they choose a point on the object. And the point they choose is right here. And they say, no, for this to move to this, what happened? For this point here, to move to this, what happened? That is what basically the question is asking. All right? Okay. All right. Or if you're going the other way, you reverse the order. All right, that's what it is saying, all right? Okay. All right, so what are the characteristics of a translation? What are the characteristics of a translation? After translation, the shape will have the same shape and size. Same orientation. Orientation means that if it was facing upright this way and it moves, it's still facing upright. It don't turn or twist. It remains in the same. Well, there's a word that I'm not going to use here, but that's a word in the math books they use, a word starting with E. Right? I might get myself into trouble if I use that word, right? But it is in that upright position. ERECT, that's the term. ERECT. Okay, that's the position. All right. All right. Translation again. Okay. So let us say we have that object. And we normally start with translation because it's the easiest thing for us to know about. Right? And the object what? Translate shape C with vector 2, 3. So let us say that is the object. And we're going to move it by 2, 3. What happens? Okay. So it's 2 on the horizontal and what? 3 on the vertical. Okay. So everything moves. So if you notice, that is where the object moves. So we add the object, we add. So what do we add? That's what we do, we add. Right? So we add the object points to the translation to get the image. All right, on that translation. Okay. So this is another example. Let's try this one. And if you notice here, students, there are 2 approaches again. You can figure it out or you can work it out. Right? If you notice the coordinates for this is not listed. But what is happening in CXC now, they are not necessarily giving you these in worded form. They drawing the diagram and giving it to you. So you have to figure out are they going to write on the coordinates and work it out, or you just going to reason it out. Okay? All right. So basically translation is just adding the object to the image. And this is what is just happening here is just setting what happens for you to move from the object to the image. Right, that's all that is happening here. Right? And the object just moves. So I think we have spent enough time on translation. And this is the second example Q. It shows the example Q. And what's the translation? Translation is what? 3 minus 5. All right. Okay. Let's got reflection now. Reflection. Reflection. What is reflection? Reflection is not shape is reflected. We have something known as a line of reflection or the mirror line. Okay. To draw the reflection, first you have to draw the mirror line. And all right. Okay, so let's go into what a reflection actually looks like. So let us say that is, and notice most of the examples that I'm giving involve using the graph, because CXC in these newer times after COVID, the emphasis is on visual representation of the graph, putting the object on it, and then sometimes the image, and then ask you several questions in terms of what is happening. So you now have to look at what is there and determine whether or not it is a reflection, a translation, or an enlargement based on what is there. Okay? So let us say that is the object S, and what S is going to happen now. Okay? The line y equals 0 and y equals 0. Okay? The line y equals 0, that is going to be the mirror line, the line that is highlighted there, and it's going to reflect it over that line. Okay? And we say equal distance away. If you notice, it is 3, the first point highlighted there is 3 units away on the same side. So it's 3 units away on the other side. Okay? Okay. Same thing for the second point there. And then out for the third point. Third point. And what do we have? We have the reflection. So S would be the object, and S prime is the image. Okay? Here again, I said the example asks us to find the, give us this and ask us to describe this reflection. And this reflection would be a reflection in the x-axis. And the reflection in the x-axis is the same thing as a reflection in the line y equal 0. Okay? Still a reflection in the x-axis. Right? The x-axis is the mirror line. Okay? Let's cut another one here. And this time we're going to reflect it in the line x equal 2. Okay? X equal 2. If you notice, I'm doing different types of reflection. So I'm not just looking at just the whole concept. You have different mirror lines that can be used on the graph paper. So of course, it's going to go across on the other side of the mirror line. Right? So, and this is another way of doing it. If you are not so excited about writing off the coordinates and try to use a formula to work it out. So you have an option for those persons who don't like the word of calculation. This is another way you can estimate where the image would fall. Okay? All right? Reflection on the other side. All right, and that's the image right there. So you have an option. It's either you calculate or you estimate using the graph paper. And that is why, part of the reason why CXC has realized that other persons are visual learners and have created the exam to more user-friendly when it comes to like these topics. Because once upon a time, back in the days, people had to actually draw the triangles and do the calculations, and persons find it more challenging at that time. Because a lot of persons, had it difficult, especially even drawing up graph paper properly and all of that. All right, so let us look at this one. Y equal X. This is another mirror line. This is another mirror line. That's another mirror line. Y equal X. That's another mirror line. Y equal X. How do we reflect over the line? Y equal X. It's another mirror line. Right? That's the first point. That's the second point. And that's the third point. Right? And it's a reflection on the line Y equal X. Or you can use the formula to work it out. So far we have looked at different. So we looked at reflection on the X-axis, reflection on the Y-axis, reflection along the X, reflection along the Y, reflection on the line Y equal X. Okay? And that's reflection. Okay? So we're going to move on now to rotation. Okay? Rotation. And rotation is a little bit more technical, meaning that you can't necessarily estimate where the points would fall. So this is where now I would encourage you to, it can be done this way, but I would encourage you to try and use the formulas to assist you. Okay? You could use the formulas to cheat sheet to assist you. Right? You could use the formulas to assist you, and it will make life a little easier for you. Because for rotation, right? So we're looking at, all right, so I'm coming back to the other presentation, but take a larger. Could you just scroll down to rotation for me? Rotation is at the end. Okay, go down. So a rotation, stop right there. A rotation can be achieved by performing two composite reflections, which I alluded to earlier on. The result, rotation, will be double the amount of angle formed between intersecting lines. Rotation is isometric and do not preserve orientation. The shape is the same, but the shape remains the same, but the orientation changes. So it spins, turns, etc. Okay? Rotation of 180 degree is equivalent to a reflection. All right, so when we look right there, let's look right there. You notice the formula to work out rotation is right there. Clockwise rotation of 90 degrees. Sorry, counterclockwise rotation of 90 degrees is the same thing as a clockwise rotation of 270 degrees. And that's the formula you used to work it out. Those three formulas you need to try and remember very easily. And counterclockwise is the same thing as anticlockwise. For 180, either way is the same thing, and I alluded to that. So 180 degrees clockwise, when you put it in the same position, if you go that way or that way, it's going around the world. If you go around the world one way, 180 going around the other way, same place you're going, right? At 270 degrees now. 270 degrees anti-clockwise is the same thing as 90 degrees counterclockwise. All right? So we're going to go back to, right, so we're going to go back to the rotation. We're going to come back to that cheat sheet when we are finished. All right? All right, so let's look at this. Rotation of 90 degrees clockwise through the origin. So what I would want you to do for me now is to use I'm going to give you some time to figure out where the coordinates would fall. Where the coordinates would fall, right? Based on the formula that we used on the cheat sheet a while ago, right? So we're going to go back to the cheat sheet and look at the formula. See, that's the cheat sheet. Clockwise rotation of 90 degrees, right? Or 270 degrees, like that. So please look at that quickly. So we're going to write that off. And then we're going to go back to the question now. Okay, we're going to go back to the question. I said, clockwise rotation of 90 degrees about the origin. Okay, so center of rotation is 0, 0. Okay, so after using the formula, what would we get? All right. And that is where it would go. Clockwise rotation based on our calculations. Okay, that is where it would go. Right? Using the formula that I would have given to you. All right? Moving on. All right? Clockwise rotation of 180 degrees. Okay, let's move on to the other one. 180 degrees, it would fall on the others. So if you had gone clockwise or anti-clockwise, it would have fallen in the same place. Okay? All right. Okay. Now rotate anti-clockwise. So anti-clockwise means that we are going in the other direction. So what I recommend that you do is to use the formula that I showed on the cheat sheet. Eventually, we're going to go back to the cheat sheet, but for the time being, I'm just going to show you what the rotation will look like, anti-clockwise rotation. So that is where it would fall on the other side here. Because it's going anti-clockwise. And how would you work this out? Use the formula that I gave you to work it out. All right? I'm going to come back to the formula. All right? All right, so let's go again. That is where it would fall. After it's an anti-clockwise rotation of 90 degrees. And you'd use a formula to work it out that I gave to you. Okay? All right. Let's cut this one now. Sometimes the center of rotation can be inside the object. Sometimes the center of rotation can be inside the object. In recent times, CXC has shy away from this because it's very difficult for students. However, you may never know. But the center can be inside the object. All right. So if you notice, the object turns. Right. In a case like this, what they could do, they could give the object and the image and ask you to describe what type of transformation that has taken place. Right? And so they could give the object and the image and ask you to describe the transformation, which you know is a rotation, and they could ask for a question like to describe the rotation. Right? And if you notice what I said earlier on, whenever you are describing a rotation, the three things that you use to describe the rotation is the direction of the rotation, the angle of the rotation, and the center of. So if you notice in this rotation, what was the description? It's a clockwise rotation of 90 degrees about the point 1, 2. So just remember at all time when you are describing a rotation, that is how you describe a rotation. Okay? All right? Enlargement can be the easiest one because either the object gets larger or it gets smaller. Right? Enlargement, however, there's something that I had not pointed out. Enlargement still has a center of enlargement. Normally, CXC avoids stressing you out and allow the center of enlargement to be the origin. But though you can't assume that all the time. I think I've seen a question in recent time where the center of enlargement is the point where everything extends from. You see where the X is on this diagram? Where the X is on the diagram there? That is where the center of enlargement is. So you have to be careful now, all right? Right there. Go back to I'm going to show you what I'm talking about. No, my computer. Let me go back to where. Okay, yep. All right, when I finish the presentation, what I'm going to go back to the enlargement and show you where the center of enlargement actually is. Okay. All right, so let's look at this shape. All right, if you know where the red X is, the red X, center of enlargement would be the origin in this case. Right? Center of enlargement is the origin, meaning that everything is going to extend from that point. Extend. Right? So, yeah. You notice where the line is extending from? The center of enlargement. Notice? Right. All right. So in an exam situation, there are two challenges that you could get with a question like this. Two challenges. What are the two challenges? What is the center of enlargement? And what is the scale factor? Those are the two main questions that could be posed to you here. All right. Now, in order to work out the center of enlargement, what you can do, you can draw a line from the connecting all object points and image points and move it towards normally move it towards the origin in that direction. And where all of the points connect, that will be the center of enlargement. If you notice, so you connect all of the object points and image points. So you connect P to P prime and the other points. And where all of them gather right there would be the center of enlargement. How do you find the scale factor? You look for a side on the object and a side on the image. And you divide the image side by the object side, the distance, and then you would find the scale factor. Right? So let me go again. You divide a side on the image, divide by a side on the object. The length of a side on the image divided by the length of a side on the object. Right? And that is very easy. Right? In the exam situation, you can maybe use a rule and measure it. I mean, yes, you have formulas where we can also calculate it, yes, but I try to make it as simple as possible. You look for the length of a side on the image divided by the length of a side on the object. Very basic. Right? Because I don't want to go into the x2 minus x1 and all of that. Because people go and get thrown off with that. All right? Okay. Okay, let's look at another example here. Enlargement. When the scale factor is a fraction. So when the scale factor is a fraction, obviously the image is going to be smaller. Okay, it's going to be smaller. All right. See there, right? Hold on, sorry, go back to that. Right? So see another situation here. So you can get it in reverse. You can get a thing where the scale factor is greater than 1 or when the scale factor is less than 1. Right? When the scale factor is greater than 1 or when the scale factor is less than 1. All right? Okay? All right. Let's look at another situation now where scale factor is 3. So you get that on the paper in the exam and they say to find the image. And the scale factor is 3. So the easier way is to write down the coordinates for each of the points and then multiply by 3. That's an easy way to do it. Right? So you write down the coordinates to the object and multiply by 3. So if you do that, right. But if you notice in this case, the center of enlargement is inside the object. So here again, suppose CXC exam, they give a situation like this now. So guess what they're going to do now? They give the object and they give the image. I'm going to ask you to find the center. Two things they're going to ask you from this question. They're going to ask you to find the center of enlargement and they're going to also ask you to find the scale factor. So to find the center of enlargement, you connect all of the object points to the image points, right? And where all 3 lines meet, right there, that is the center of Okay. All right. So let me go to the cheat sheet now. Cheat sheet. Cheat sheet. Okay. So cheat sheet from the top. In summary, reflection is a flip. Okay. And we have the formulas there for line of symmetry. The lines of symmetry is actually the line that it flips over. So for the x-axis, reflection, in the x-axis, x remains the same, the sign of the y changes. For the y-axis, y remains the same, x changes, y equal x, the x and the y flip around, and there's another one, y equal minus x, but okay. I have x or around the origin or 180 degrees. That's the reflection there. So through the origin or 180 degrees, that's the minus x minus y. Let's go down to translation. What's a translation? It's a slide or a shift. Translation can be achieved by performing two or more reflections, parallel lines. Translations are isometrical and preserve orientation. So for translation, what it's saying, shape remains the same. No change in the shape. Either it get bigger or smaller. Right? All it is and the formula, you just add the translation again to the coordinates. Right? Dilation, in enlargement or shrinking. Right? You just multiply by the number, which is known as the scale factor. The scale factor can be greater than 1, or the scale factor can be less than 1. Okay. Rotation. A rotation is a turn. Okay. So if the rotation is a turn, it simply means that the image and the object is not going to, the isometry is not going to be preserved, means it's going to turn in one direction. And these are the identities for the formulas that you use to work out the rotation. So try to remember these. I try to get them as simple as possible. There is the other method of giving you the identities in terms of the matrices. At this stage, if I give it that, people going smoke when start coming out of their heads. I don't want to. Well, if you like it that way, fine. But this is an easy way that you can use to remember the transformations, right? So basically, once you remember these, you won't have any challenges doing them in exams, right? And just remember now that if you're asked to describe a transformation, then you have to describe it based on the object, what the object looks like, and what the image looks like, basically, right? So that you can know that a rotation is different from an enlargement, or an enlargement is different from a reflection. And that's how it is. So in summarizing transformation, as I say, in the exam, they'll do a lot of merges there, meaning that they combine rotation with reflection, enlargement with rotation, etc. You just have to read and understand what is happening. You just have to read and understand what is happening. And as I said, most of the questions are visual. They will be drawing the graph paper and putting the objects and the images on it. So it's a matter of reading, practice, and trying to ensure that you get as much experience with these questions. The more experience you are with these questions by practicing, then when you see a question, you will be able to. I'm just going to touch back a little bit on the center of enlargement with. I'm just going to go back to something here. Go back to something here that I did. Just a second. All right, good. So let me just go back to something here. Okay. Let's go back to something here. just for this record, for enlarge for center of, I think it was this one, right? So if you note this would be the center of rotation, center of enlargement, right? So if I were to draw it, it would come straight down to this point here, right here, center of. So whenever you're describing a enlargement, two things must come into it: the scale factor, and if you notice the scale factor here will be 2, and if I were to draw it down, it would if I were to draw it down, let me move, right? Let me do that. This. Okay, so I think that's that. You get the idea of what I'm talking about. That the center of enlargement is where everything moves away from. Everything will move away from, right? I think that's that. So it was nice having you come to the seminar today. As you know, it is a workshop, so we can't do everything at a workshop. We have to do a summary. I can't give you too much information because you'll get an information overload. But I think I did a brief summary of what is expected as far as transformation geometry is concerned. And I hope you benefited from the workshop. We try and see if we can get the PowerPoints to you. And I hope that the workshop would have assisted us to improve our overall knowledge base as far as these 2 topics are concerned, as well as ensuring that we look at some of the study tips, which I'll be doing a little quick revision of them close to the end of the session. So I'll break for now and come back in a few minutes to give you a few more tips in order that you can build your confidence in mathematics.
Thank you so much, Mr. Hilton. We certainly enjoyed your session on mathematics. Of course, we wish we could have you all day, but we understand, it's just a workshop, but we're really grateful for you, and we thank all of you who joined us on our Instagram as well as the Zoom platforms. I really hope you got to revise some stuff, and for those of you who may have been hearing some of it for the first time, hopefully not, you would have learned something today. Congratulations to our winners from today for the national snack baskets for yesterday and today. And of course, remember to come to our office to collect your baskets, speak with your parents and organize this. It's 40 to 42.5 Beechwood Avenue, Kingston 5. That is off Half-a-Tree Road or off Lyndhurst Road, depending on which direction you're coming from. Very close to National Bakery, of course. And I want to thank National for their sponsorship of this workshop. Could not have done it without you. And we continue to support your products and your cheesy bowls. I promise you it is really delicious. And if you haven't tried it as yet, please get yourself a pack. Now, we also want to tell you that for the website, for the study center, if you're having difficulties logging on, shoot us an email or call us at our head office. Now, it's www.jamaicaobserver.com/study center. If you're having any difficulties, send us an email at ASHERK, that's Asher K, ASHERK @jamaicaobserver.com, or call our head office at 926-7655. Either option will work. Once we get your email, we will get in contact with you and see what's the difficulty you're having, if you're having any difficulties locking on. So that's 926-7655 or ASHERK @jamaicaobserver.com, so we can work with you on accessing all those lessons that we have stored up just for you. All right, so my name is Casey Asher Dawkins. I'm the editor for the Study Center, and we wish you all the best in your exams. I know you will do just fine. Just study, do your work, practice. Mr. Hilton said mathematics is practice and experience. Get your practice in, and I'm sure you will do just fine. On behalf of Jamaica Observer, we want to say thank you. On behalf of National, can I say on behalf of National? Is that okay? Yes, on behalf of National, also, we want to say thank you. And of course, we will see you. Send us an email though, if you can, and let us know how the exam went. You know, I want to get your feedback to make sure that you are just as confident for the other subjects. Alrighty, thank you much, and you take care. 926-7655, asherk@jamaicaobserver.com. Call or email if you're having any problems logging on to our study center online. Take care and have fun.
The Jamaica Observer Study Center Online is giving you more. CAPE Mathematics and Management of Business have been added to our Study Center Online to better prepare you for your final exams. Gain access to over 10 free CSEC and CAPE lessons, available this and every Tuesday. Visit us at jamaicaobserver.com/study center or contact us at 876-844-2107.
Cheesy balls. National cheesy balls. National cheesy balls. Shockingly cheesy. Cheesy balls. National cheesy balls. National cheesy balls. Shockingly cheesy. Cheesy balls. National cheesy balls. National cheesy balls. Shockingly cheesy. Cheesy balls. National cheesy balls. National cheesy balls. Shockingly cheesy. Cheesy balls. National cheesy balls. National cheesy balls. Shockingly cheesy. Cheesy balls. National cheesy balls.
Thank you, Mr. Henry. That was, Mr. Hilton. Mr. Hilton, I'm so hungry. That appetizer really just got me up. But never fear, we'll soon go and get our refreshments. And I am positive I'm going to get some cheesy rolls to fill me up. So thank you, Mr. Hilton. That was really, really very good. I learned quite a lot. All right, so what we're going to do now is we are going to do some giveaways courtesy of our sponsor, National. And basically, you are going to, I'll just ask you some questions, and we are going to be giving away this lovely basket. And we have 3 questions, so you have 3 chances to win. And basket. Lovely. All right, so our first question is, get ready. What year did National Bakery open? What year? What year did National Bakery open? Easy cheesy. What year did National open? What year? So just send your answers in. I will let you know when we have a winner. And you can browse that through. Think about it. What year did National open? And I know you know the answer. Don't be shy. Just send it in. No, we got some answers. Not so right. Not that. Not that. Try again. We're getting some answers, but they're not so correct. Let me give you a little clue. Come further. Further. You're too far back. Come further. Closer to independence, but not so close. Not too close. Oh no, you're gone way back. That answer was way back. Come further. Further, further, further. All right, we got the answer. It is 1952. That was the year that National Bakery was opened, 1952. So congratulations. We're going to tell you who the winner is, but you know yourself, the person who sent that answer in. So congratulations. And of course, this deliciousness is yours. All right. Now, our second question. Woo, this is interesting. Who is the owner of National Bakery? Who is the owner? Who is the owner? Who is the owner? This one not as easy as the last one, but it's not so hard either. So who is the owner of National Bakery? Easy cheesy. Who is the owner of National Bakery? All right. So send those answers in. Let me give you a teensy-wincy clue. Teensy-wincy. No, I'm not going to give you that clue. Let's leave that one where it is. The man's name. We're getting some answers, but the answer's not so accurate. We want the name of the man. See, that is the clue. Have a winner? All right, great. You guys are bubbling mad. So we have the winner. The answer is Gary Hendrickson. All right, so congratulations. You know yourself. We'll soon release the names of the winners so you can come and get your basket. All right, so the third and last question.
I won, guys. I won.
This one is so easy. I want to see those answers just flowing in. Okay. What is the name of the cheese snack that is featured today? What is the name of the cheese snack that is being featured today? From National, of course. All right, easy cheesy. What is the name of the cheese snack that is being featured today from National? All right, the answers are coming in. I see them coming in. Let's see what you guys are up to. What is the name of the cheese snack that is being featured today? All right, let me see if I can give you a little clue now. Oh, well, it's on your screen. That's a big clue. No? All right, that answer that came in just now was not correct. It's on your screen. That is a humongous clue. So let me see those answers coming in. But let me see now if I can give you a clue. It rhymes with the person who does this. Let me see. Yes, we got a winner. Awesome. The answer is cheesy volts. And of course, the person who does this is Usain Bolt. All right. So the answer is cheesy volts. That is a cheese snack that's being featured today. So make sure you run and get one as soon as we go for our break. Now you have a little time to refresh yourselves, but remember, right after we finish this, when you are preparing for your CXC exams, remember Study Center Online is available to help you with not just math and English, but all the other subjects that you will be doing in your exams. So just contact us when you're ready to go on if you're having any difficulties. We have a brand new website, so we just try to sort some things out. But remember, the Study Center Online is available for you to get some help for some additional lessons. All right, now the winners are, number one, the winner is Twinkle.Perry. Twinkle, twinkle, little star. Twinkle.Perry. Congratulations, Twinkle.Perry. And the second winner, wait, Shante Martin again, you're a star man. Wait, Shante, thank you for entering again. Shante Martel. If I got it wrong, it's SHANTAIMARTELL. So I'm assuming it's Shante Martel. And the third winner is Leah Melly. Is that correct? KAELIAMELI. Leah Melly, congratulations. All right. Remember to get your baskets at the Jamaica Observer We're at 40 to 42 and a half Beechwood Avenue, and do not miss out on the deliciousness. All right, lots of people would love to have this, so make sure you come and you collect it, courtesy of National Bakery. Thank you, National. So run along, get something to eat, get some water, refresh yourselves, and we'll see you back at, let me see what time, at 12:45 shortly. See you.
Chocolate cheesy balls, national cheesy balls, national cheesy balls, shockingly cheesy. Chocolate cheesy balls, national cheesy balls, national cheesy balls, shockingly cheesy. Chocolate cheesy balls, national cheesy balls, national cheesy balls, shockingly cheesy. Chocolate cheesy balls, national cheesy balls, national cheesy balls, shockingly cheesy. Chocolate cheesy balls, national cheesy balls, national cheesy balls, shockingly cheesy. Chocolate cheesy balls, national cheesy balls, national cheesy balls, shockingly cheesy.
The Jamaica Observer Study Center Online is giving you more. CAPE Mathematics and Management of Business have been added to our Study Center Online to better prepare you for your final exams. Gain access to over 10 free CSEC and CAPE lessons. Available this and every Tuesday. Visit us at jamaicaobserver.com/study center or contact us at 876-844-2107. The Jamaica Observer Study Center Online is giving you more. CAPE Mathematics and Management of Business have been added to our Study Center Online to better prepare you for your final exams. Gain access to over 10 free CSEC and CAPE lessons. Available this and every Tuesday. Visit us at jamaicaobserver.com/study center or contact us at 876-844-2107. The Jamaica Observer Study Center Online is giving you more. CAPE Mathematics and Management of Business have been added to our Study Center Online to better prepare you for your final exams. Gain access to over 10 free CSEC and CAPE lessons. Available this and every Tuesday. Visit us at jamaicaobserver.com/study center or contact us at 876-844-2107. The Jamaica Observer Study Center Online is giving you more. CAPE Mathematics and Management of Business have been added to our
Chocolate cheesy balls, national cheesy balls, national cheesy balls, shockingly cheesy. Chocolate cheesy balls, national cheesy balls, national cheesy balls, shockingly cheesy. Chocolate cheesy balls, national cheesy balls, national cheesy balls, shockingly cheesy. Chocolate cheesy balls, national cheesy balls, national cheesy balls, shockingly cheesy. Chocolate cheesy balls, national cheesy balls, national cheesy balls, shockingly cheesy. Chocolate cheesy balls, national cheesy balls, national cheesy balls, shockingly cheesy. Chocolate cheesy balls, national cheesy balls, national cheesy balls, shockingly cheesy. Chocolate cheesy balls, national cheesy balls, national cheesy balls.
The Jamaica Observer Study Center Online is giving you more. Cape Mathematics and Management of Business have been added to our Study Center Online to better prepare you for your final exams. Gain access to over 10 free CSEC and CAPE lessons. Available this and every Tuesday. Visit us at jamaicaobserver.com/study center or contact us at 876-844-2107. The Jamaica Observer Study Center Online is giving you more. Cape Mathematics and Management of Business have been added to our Study Center Online to better prepare you for your final exams. Gain access to over 10 free CSEC and CAPE lessons. Available this and every Tuesday. Visit us at jamaicaobserver.com/study center or contact us at 876-844-2107. The Jamaica Observer Study Center Online is giving you more. Cape Mathematics and Management of Business have been added to our Study Center Online to better prepare you for your final exams. Gain access to over 10 free CSEC and CAPE lessons. Available this and every Tuesday. Visit us at jamaicaobserver.com/study center or contact us at 876-844-2107. The Jamaica Observer Study Center Online is giving you more. Cape Mathematics and Management of Business have been added to our Study Center Online to better prepare you for your final exams. Gain access to over 10 free CSEC and CAPE lessons. Available this and every Tuesday. Visit us at jamaicaobserver.com/study center or contact us at 876-844-2107. The Jamaica Observer Study Center Online is giving you
Cheesy balls. National cheesy balls. National cheesy balls. Shockingly cheesy. Cheesy balls. National cheesy balls. National cheesy balls. Shockingly